situation. Instead of clipping manually using Sonar Wiz, we decided to try a different approach. And our colleague Tomas Malinsky from the University of Delaware wrote a code in Python that automatically cuts the entire transect with 800 by 800 pixels in size and into 550 images. So that can be done in under a minute instead of a day, which is already a huge time saver. This is just a workflow to represent my macro that I made in ImageJ. So ImageJ is an open source image segmentation software. It's originally used for biotechnology, looking at electron microscope pictures. So it did take a lot of finagling to get it to work on sonar images of fish. But it's written in Java, and this is a basic workflow. It starts with a bandpass filter, which just eliminates busyness. An RGB stack, which is a red, green, blue stack, which pretty much smooths out more busyness and amplifies features like fish and rocks. Smoothing and filling and water shedding is if you have a fish that's missing pixels, it'll automatically fill in those pixels. And adaptive thresholding is pretty much where most of the work went into. Every RGB image, the pixels are assigned a value 0 to 255. 0 is black, 255 is white. Since sturgeon are bright, I had to find their adaptive threshold, which is the value 242 to 254. These processed images were saved and then uploaded into another open source program called Weka. Weka is a machine learning program. It's pre-trained, so that has some pros and cons. It's open source and easy to use, but it's not very flexible, and it takes a while for processing. But it uses a random forest process, which is essentially a true or false Boolean decision tree. So over time, using that process, it can figure out what pixels are sturgeon, what pixels are not. It's easy to use, but it's pretty clunky. These are the outputs from Weka. It outputs only sturgeon and anything else around that 243, 255, 254 range, which could be some rocks, but it's mostly sturgeon. And just to make sure that we're only counting sturgeon, I bring it back to ImageJ. This is where we make the image binary, so you see it's only black and white. Analyze particles and circularity. So circularity is the oblong shape of the sturgeon, and over trial and error, we figured out that a sturgeon is 0.6 to 0.9 circularity almost every time. And these are the weighted values. They can be changed if you have changes in your data, but most of the time it's 0.6 to 0.9 circularity in that same threshold. After you use these weighted variables, it outputs an actual count of the sturgeon you have in each image automatically. So for last year's season, we did a comparison of human counters to the machine learning program. And as you can see, it's pretty close. It's hard to compare because the human counters are also very variable. So you could almost use this as like a standardizing of human versus machine learning. And that second figure is the total counts for this year. So some challenges and solutions with using image segmentation and machine learning. So variation in image clarity. It's not an exact science while you're out there in the winter tugging something behind you in cold water and boats going by. So you're gonna have some busier pictures. There are some bright rocks that are within that image thresholding that can be confusing to the program. And different humans count they're very variable. You can't really count on each human to be the same. Processing power, since these programs use your CPU, if you have a bad computer, you're gonna have trouble doing this quickly. And as I explained before, WECA is a pre-trained machine learning model, so you can't really change the coding yourself. And it's in Java, which is not the most accessible coding. Future evolution, so deep learning is where I think this will end up. I've already started using it, and it's more accurate than machine learning. It's another type of AI that's related to machine learning, but instead of using feature extraction and random forest process, it uses image classification and object permanence. So it's actually trying to replicate the way humans think in a way. The most accessible deep learning architecture right now is something called TensorFlow. It's a neural network. It's coded in Python, and it's used for image semantics. There's a ton of image segmentation libraries on Python as well, so I wouldn't even have to use ImageJ. It could all be contained in this one Python script and trained with thousands of fish masks that we already have. The code and weighted variables can be changed very easily because I'm writing the code myself instead of a pre-trained model. And it's fast processing because it's remote cloud-based. So you can use it in Python, or you could even use it in Google Colab. So this doesn't have to only be used for short-nosed sturgeon. It can be used for many applications where you need to automate classifying an image. So these are just some examples, but anything you think of, I'm sure it can be changed, the codes and the weighted values to accommodate for that. So the reason I've tried to stick to open source free programming is because I know there's a lot of small teams that don't have much funding in this field. And with this program, you don't need a whole team of people coding and checking and counting. You could just have one person and a code that does that for you. Yeah, that's it.
Nice. We do have time for questions.
Yeah, for that other applications slide that you just had up, were those photographs or also scans?
These are for the top, is what you're talking about?
Yeah, like for fish egg eyes and.
Yeah, so those are photographs from the microscope,
Okay.
electron microscope. That shipwreck's a sonar image, so it can be used. It can even be used with video too.
And how much is the sonar that you took?
The Edge Tech,
Yeah.
it's pretty pricey. I think between $10,000 and $20,000.
Right, yeah.
$40,000.
Okay.
So yeah, that's exactly why I mentioned small teams and how cheap it is, because you can even use it with a depth finder on a boat.
Yeah.
Yeah.
Who owns that side scanning sonar? Is it Delaware State?
University of Delaware.
University of Delaware?
Yeah. It's John Madsen.
John Madsen.
Yeah.
I was wondering if there's a way we could use it to sweep just outside off Rockaway somehow. Look at sturgeon over there.
Put together a project and pay him something, I'm sure.
Well, it's the money, it's the...
Well, if you can't afford it, you could just use your depth finder.